Okay, in this video, I'm going to go over factoring because it's such an essential skill when you get to, starting out in algebra for pre-algebra, and then once you're getting along, like once by the time you're in like algebra 2, there's a lot of factoring involved. And in some cases, some people just don't really, 6th, 7th, 8th grade doesn't sink in, and then they get to algebra 2, and they feel like they're drowning a bit. So I want to go over a bit on factoring, just factoring basic terms. I'll show you a couple of methods that I use that I find that can be helpful. All right, so the method I like to use is called the ladder method. Now, how does this work? Now, I'll show you an example here. Say I have like a polynomial here, like I have x over, let's say, I'll come up with a good number here, 60. All right, now using the ladder method, this is how it would work. I'm going to use 60, right? Now, I want to break this down to prime factors, so it's all prime numbers. First thing I can do is a lot of people would just try and list them all outright. What I'm going to do is I'm just going to divide it by any number that pops into my head, like an easy number. I know 60 is even. I could divide it by 2. I could divide it by 10. Really doesn't matter which one I start out with. I'm going to start out with, let's say, 2. All right, so if I do 60 divided by 2, I get 30. So then I figure, okay, what can I divide 30 by? Really doesn't matter. I can pick anything. Maybe I want to go with 2 again. That'd be fine. Divide 30 by 2, okay. I get 15, okay. What can I divide 15 by? Really doesn't matter. I can pick anything. I'm going to go with 5. 15 divided by 5 gives me 3. And now I'm thinking, is there anything I could divide 3 by? Not really. I can divide 3 by 3 to get 1. I technically could do that, I guess. And ideally, that's where you can get to. And I've just broken this down to its prime factors. So the prime factorization of 60 would be 2 times 5 times 3, and you really don't need to include the 1. So that's a nice, easy way to factor something. You don't really have to sit there and do like a factor tree or anything. A lot of people like to do that, but I kind of like this method. So I'll go with another number here. Say I wanted to go with like a bigger one. Like say I had 3x over 164. And I wanted to break down 164 because that's my denominator. For some reason, I want to factor that out. Here's what I would do. I'd start with 164. And I can divide it by anything that goes into 164. It doesn't matter what I start with. So I can look at here. I usually like to think, okay, if it's even, I'll start with 2 because you can always divide by 2. All right, so then if I divide 164 by 2, I get 82. Okay, what can I divide 82 by? I can divide 82 by 2 again. Why not? And then I can keep going. Let's see, 82 divided by 2 gives me 41. And frankly, I can't go any further with this. So then my prime factorization would be 2 times 41. And the beauty of this method is technically, some people are like, well, say you want to start with 4. Sure, I could do that. Okay, divide that by 41. Okay. So I get 4 times 41. And I'm thinking, well, the 4, I can do 2 times 41. It's a lot easier to break it down this way, I find. That's why I like this ladder method. Some people like factor trees. I find this very helpful. Now, what trips some people up is when they're doing polynomials, so trying to find the greatest common factor of a polynomial. So say I have one that looks like this. All right, I'm just going to make one up. I'll do x plus 1 over, say down here I'll have 5x to the third minus, we'll say, 35x. Okay, this is how I would do it. I break it up just like so. 5x to the third minus 35x squared, just x. And then I'm going to figure out what can I divide both of these by. What's a common factor here? I can divide both of them by 5. Okay. 5x to the third divided by 5 leaves me with just x to the third. Negative 35x divided by 5 leaves me with negative 7x. Okay, and then I figure how can I break this down further? X to the third minus 7x, I can divide them both by x. If I do that, then I'm left with x squared minus 7. And I'm looking at x squared minus 7. I can't go any further with that. So then I could just rewrite my problem as I go. It's on the left here. This goes outside my parentheses. Whatever is left on the bottom goes inside my parentheses. And I've just factored my polynomial. And I can do it in a couple of steps. I don't have to do it thinking all at once. That can trip people up. Let's try another one. So I'll go with, again, it really doesn't matter why we're on the top right now because I'm just focusing on denominators. And then down below here, let's go with, let's say, all right, 45 x squared minus, we'll say, oh, I got a good one, 81x. And this is how this can work out pretty well. Now, some people might look at this and say, okay, 45x squared minus 81x. Maybe they're stuck initially. So you figure, okay, I can divide everything by x. That leaves me with 45x minus 81. Now, they're looking here, and they might be stuck on some factors, but then they remember, hey, I can divide everything by 3 here. So let's start by dividing everything by 3. Now, some of you might be thinking there's a larger number here, but I'm doing this for a reason. Follow along. 45x divided by 3 gives me 15x. 81 divided by 3, or negative 81 divided by 3, gives me negative 27. Now when I get here, I'm looking 15x minus 27. Hey, I can still divide that by 3 again. So if I do that, I get 5x minus 9. Now I'm looking at 5x minus 9, nothing I can factor out of there. So then, what do? This goes on the outside. This goes on the inside. So I would do x times 3 times 3, all times 5x minus 9. I can simplify x times 3 times 3. 3 times 3 gives me 9. So I can rewrite this as 9x times 5x minus 9. And some of you might have jumped to it immediately and said, yeah, I knew 9 was a factor. But that's the beauty of this. You don't necessarily have to recognize the largest factor. You can start small and build off of that. I think that's great about this method. So using this ladder method, it's good for breaking down prime factors. Just going one step at a time, going small. I like going like that. I like always starting with 2, starting with 3, 5, those basic prime factors, and then just going step by step. Because again, sometimes it's hard for us to see that big number that jumps right out at you. So going step by step can be very helpful. I always recommend starting with 2. And then for when you're looking at the polynomials like this, it's the same principle, except you're just dealing with 2 numbers. You're dealing with 2 terms, rather. You're dealing with 5x to the third and negative 35x in this case. And then in this case, you're dealing with 45x squared and negative 81. So you're trying to find factors that work for both of them. Hopefully this helps you out a little bit with factoring. I know, especially if you had trouble with it in the past, it can be a lot to catch up on. But at least this is a method that can kind of help you catch up a little bit. And that way, if you're working with some more difficult expressions, you at least have a place where you can start out and have a little bit of confidence.